In this demo, we'll continue looking at ways to support options reloading in the tennis booking application. So far, we've used two of the free available options interfaces to access the options instances. I'll now introduce the third interface, iOptions Monitor, and we'll learn how this is subtly different to the first two that we've used previously. For this demo, we'll focus on the Greetings feature, responsible for providing randomized greetings used in two of the views. Here is the Greeting Service class. Currently, this accepts an iOptions of greeting configuration, which is consumed similarly to what we've seen previously. The configuration is used to set the greeting color property for the greeting service. The Greeting Configuration class contains a single property to which configuration can be bound. The greeting service is injected into the index model and is used to set a greeting color property on the index model. The Razor page for the index accesses the greeting color from the model to style the header. We'll now provide the configuration for the greeting color. Inside the app settings JSON file, we'll add a new subsection below the features section. We'll add a new configuration key called greeting color with a string value that provides the hex value for the greeting. We'll start with the hex code for black. What else do we need to do to apply the options pattern here? That's right, we must register the configuration to be bound to our options class. Inside the program file, we'll copy this configuration registration and tweak it for our greeting configuration. The options class to which we want to bind is the Greeting Configuration class. We'll bind configuration entries from the Features::Greetings section. If I run the application, as expected, the greeting is shown and the text color is black. If I want to adjust the color, I can update the hex code in the configuration. Currently, saving this configuration and reloading the page does not result in the color updating. This is expected because we used iOptions within the greeting service, which doesn't reload configuration values. If I stop debugging and restart the application, the color from the updated configuration is applied when the home page loads. Let's say we'd like to have this change to the configuration apply whilst the application is running. We'll apply what we've learned so far and make the necessary change to accept an iOptions snapshot instance here. With that simple change, I'll run the application and we can expect the live reloading to occur. Oh, we have an exception. This may seem curious since we made the exact change that we used previously that worked without any problems. So what is different this time? The inner exception is an invalid operation exception. If we take a moment to read the error message, things will become a little clearer. It's telling us we cannot consume a scoped service from inside a singleton service. This is a safety feature of the dependency injection container called scope validation. The greeting service is registered with the dependency injection container as a singleton. The iOptions dependency used before this change was okay because it was also a singleton service. Having switched to iOptions snapshot, which is a scoped service, we accidentally captured it inside the singleton. If you'd like to understand more details about dependency injection and service lifetimes, I recommend you view my dependency injection in ASP.NET Core 6 course to complement your learning. This exception is a problem that we can solve by turning to iOptions Monitor. Like iOptions, iOptions Monitor is registered with dependency injection as a singleton. This fact means that we can safely inject it into other singleton services. I'll update my greeting service to accept an iOptions Monitor of greeting configuration. This now introduces a compiler error. Rather than exposing a value property, iOptions Monitor exposes a current value property. This will return the current value from the configuration. If the configuration reloads, the next time current value is called, it will have the updated configuration values. To support reloading within this singleton service, one of the most straightforward scenarios is to hold onto the iOptions Monitor instance and access values via its current value property whenever they needed. I'll comment out this field, which we'll come back to, and add a new field to hold the iOptions Monitor itself. We'll update this code in the constructor to set the field with the injected iOptionsMonitor instance. We can modify the greeting color property to first call the current value property on the iOptionsMonitor instance, and then access the configured greeting color. If the configuration in the JSON file changes, the reload will be immediately reflected via the current value. I'll rerun the application to validate all of this. When the application starts up, the greeting text is still blue. I can now modify the value in appsettings.json and save the change. When I return to the page and refresh it, the greeting text is now pink. We've now got options reloading even inside a service registered as a singleton with the dependency injection container. iOptionsMonitor also provides a way to register a listener, which gets called whenever the options instance is updated. This can be used to add a variety of more advanced behaviors to your application. For example, if our application used SignalR, we could potentially push the updated greeting color to the web page without even requiring the user to refresh. That might surprise our users though. We'll swap the fields again, uncommenting the original greeting configuration one. Initially, we'll set it using the current value from the iOptionsMonitor within the constructor. Remember, this won't automatically result in the value being updated, since the constructor only runs once for a singleton service. However, we can register some code to listen to the onChange notification. The onChange method exposed on iOptionsMonitor is used to register the listener. We can provide an action delegate for the onChange listener, where we have access to the updated greeting configuration instance. We'll define our listener code as an anonymous function. We'll include code to update the greeting configuration field with the latest configuration. But we can also perform other work within this onChange delegate, such as logging the fact that configuration was updated. There are two remaining compiler errors to fix. As we're now updating the greeting configuration field outside of the constructor, the field can no longer be defined as read-only. Finally, we must update the greeting color property to remove the need to call current value. An advantage of using the onChange approach here is that we don't need to litter all of our code with calls to current value. The onChange method returns an iDisposable, which should be disposed of when you want to stop listening to updates. Since we're registering this inside a singleton and intend for the listener to live for the life of the application, we don't need to call dispose to stop listening. So that we can see what happens whilst debugging, I'll add a breakpoint here inside the onChange delegate. If I run the application, let's try changing the configuration value and saving the appsettings.json file once again. As soon as I save the file, the breakpoint in the onChange action is hit because the configuration reload has taken place. We can see the updated greeting color on the configuration passed to this delegate. The new value is stored in the greeting configuration field, and if I reload the page, the updated color is reflected and our greeting text is now blue again.